So we're going to start in section 1 of chapter 9. We're going to talk about stoichiometry in that chapter. So what is stoichiometry and what the purpose of studying it? So that's a very, very important part, or actually stoichiometry considered one of the most important chapters in the chemistry, and it's very, very important to understand it. So to know what is stoichiometry and what is it related to, we're gonna first watch the following video just to figure out the idea. After watching this video, I need you to answer some questions. First question is, okay, what is stoichiometry? Okay, then, okay, what the purpose or how we could use stoichiometry or why stoichiometry is important. These two questions, okay, I need you to answer them after watching the video. I'm gonna collect your answers. So let's watch this video together, guys. Again, here he asks you, so regarding to what we explained through the video till that moment, okay? He asks you, how many moles of nitrogen do you need to make 10 moles of ammonia? Anyone could predict how we're gonna make it? Guys, anyone have an idea?
ثانية
What?
بفكر فيها.
Okay, just think. Guys,
Five?
please. What?
يبقى 5.
5. So
No.
you have to, so how many moles of nitrogen do you need to make 10 moles? So they are supposed to be 5. What do you think? So these are gonna be 5. Yes, how do you get it, Hassan?
ما عملنا دي times 5
How?
اللي هو ال NH3 هو هنا 2 فعملناها times 5.
Yeah, so that's mean, okay, simply you said that here is just 1 mole, okay, that represent 2 moles of ammonia, yes or no? So 1 mole of nitrogen, it produces 2 moles of ammonia. So we ask what would happen if we have 10 moles of ammonia. That means the amount which we need. So we can say that 10 mole of ammonia, okay, we are gonna multiply by the ratio here. How many mole of ammonia do we have? We have 2 mole in the equation already, okay, and this 2 mole of ammonia is already produced by 1 mole of nitrogen. So here and 2. So overall, it's fine. It's 10 multiply 1, so it's gonna be 10 divided 2, and this will cancel with this, okay? So in that case, we're gonna have it's 10 divided by 2, so 5 moles of nitrogen. Okay, you get this, guys? Is it clear?
Yes.
Okay, so here that's how to, or that's the idea, okay? That's how we could find it. Or we can just make it another way, or another hand, like as we used to do it before, okay? We can say simply 1 mole of nitrogen that produces, okay, 2 mole of ammonia. So if we have 10 mole of ammonia, so the question is, how mole do we get? So cross multiplication, very easy, okay? So 10 multiply 1 divided by 2, okay? So simply we're gonna find that 10 multiply 1 divided by 2 equal 5 mole of nitrogen. Is it clear, guys? Is it clear? Guys, is it clear for everyone, or anyone can understand? If you cannot understand, please raise your hand or ask. Okay, so let's continue to check, okay, that we are right or not, okay?
Next, multiply that by the ratio of nitrogen to ammonia in the balanced reaction. Since we are starting the problem with ammonia, we put the 2NH3 on the bottom. This 2NH3 comes directly from the balanced reaction. Because we are solving for nitrogen, we put 1N2 on the top. That 1N2 also comes from the balanced reaction. Remember, if no number is written in front of a chemical, that means the coefficient is 1. Last of all, do the fraction multiplication. 10 times a half is equal to 5. As for the units, notice that the ammonia we started with cancels out with the ammonia on the bottom of the fraction, and we are left with moles of nitrogen, which is exactly what we want. Let's try one more problem. How many?
What's meant by stoichiometry, guys?
بس أنا مش متأكد منها بس.
So just say your answer, okay? That the answer was in the video, okay, guys? The beginning of the video. So
مستر
yes.
ستايك اللي هي معناها element ومتر اللي هي process of measuring.
Yes, good. Stoichiometric means measuring, or the kind of, we measure the elements or we measure the substances. Okay, so stoichiometry, it's that's the branch of the chemistry which is concerning about measuring the elements or the different substances in a compound or in a chemical reaction. Okay, thanks, Hassan. So anyone can tell me regarding to what you watched in the video, okay, why is stoichiometry considered to be important? Or why stoichiometry is important, guys? Alia? Ali. Guys, why you didn't respond even when I call your name? I said that's happened, I'm gonna kick the one out. Okay. So then, Lolo, why stoichiometry is important?
Hi, Mr.
Hi. Why do you think stoichiometry is important, Lolo?
Mr. Not to waste time, I actually don't know the answer at all.
What?
I don't know the answer.
You didn't know the answer. Okay, just actually, it's not an answer. I just need to what you understood from the video. Okay, what do you think? Why is stoichiometry considered to be important? Why do we study stoichiometry in your mind, okay, or in your opinion regarding to what watched in the video? Jana Tamer? Jana Tamer? Jannah? Okay, Abdurrahman, Bughdadi.
Yes, Mr.
What do you think stoichiometry is important regarding to what watched in video? The example that mentioned in video, the one who need to make this kind of sandwich, so he doesn't know the way, so he asked him for a recipe. So we said stoichiometry, they are working the same. So why do you think stoichiometry is important in chemistry?
Because it helps and predict how much of reactant participates in the chemical reaction.
Excellent. Okay, so stoichiometry just represents to you the quantitative ratios between reactants and products. So if you need to work out certain chemical reaction, at first you must know how much of the reactants you need to ensure that a successful reaction will happen. So like that, that's stoichiometry which is needed. You are in lab and you are preparing some chemical substances. So to bring the ingredients or the reactants, the components of this product, you must know how much exactly they are going to react together. So that is a stoichiometry. You get this, guys? You get the idea? So that's the same like as you watch it in the video. This one to make a sandwich, okay? Or imagine that you are making kind whatever, anything in your kitchen. You're making a cake or a sandwich or whatever. You know how much you're gonna add from each substance because you cannot just add random amounts because that actually will cause or will lead to a disaster in the end. Imagine that you are cooking and you don't know how much exactly salt you're gonna add and you add whatever random amount. So it may be saltless or completely, okay, or hyper salty, and that's in that case, okay, it will, you cannot eat it, okay, and like this, the entire process is damaged. So the same here, while we are working in chemistry, we need to know the exact quantitative ratio between different substances to make a certain chemical reaction. So that's why, or what, that's the importance of stoichiometry. And as we observe here as in the video, we know that atoms, they are tiny, too small. So we are dealing with the millions, trillions of atoms in each reaction. So instead of using the word atoms or particle or molecule, we use, okay, another thing or another measuring unit, which is the mole, okay, because mole that has a fixed number of atoms, which we know the Avogadro's number as we studied in chapter 3 before. So like this, we know that. So here in stoichiometry, always we work by using moles. So regarding to what we should do with you guys, to start or to figure out the quantitative ratio between reactants and products in chemical reaction, we should have in the beginning what must we use, okay, to do this, what we use, okay, to know the quantitative ratio between substance in a chemical reaction. Who can answer this question, guys? Okay, what do you think? Hassan Ruhaib? To making a kind or to, just as you watch a video, okay, we said to make or to start to find the quantitative amounts, okay, or the quantitative ratio between reactants and products. So what represent that, or we could find this represented by using, yes, Layan? Hassan, you didn't answer me, I'm gonna kick you out. Okay, Layan? Guys, just think. I didn't ask you, just it's a kind of thinking. Show your participation. Layan?
Mister, can I answer?
Okay, yes?
Mole.
What?
Mole.
No, I don't ask about, yeah, we use the mole as a measuring unit, but what we should use, okay, to represent the quantity, the number of moles or the ratio of moles of others, of different substances together. What does it represent? We use what? That's mean, okay, what represent the quantity in the video you watch it, okay, once he told the refugee to make this kind of sandwich, he asked him to use 2 pieces of bread with 1, okay, piece of cheese to just get 1 sandwich, yes or no?
Yes.
So what does this represent in chemistry? What we said?
Chemical.
Chemical what? Chemical?
Compound.
Equation, chemical equation, guys, okay? The chemical equation or balanced chemical equation, that what represent the idea, okay? Like as you watch here in the video, he said, okay, or we just said that once and reacts with a hydrogen produces NH3, okay? So nitrogen reacts with hydrogen to produce ammonia. This is a chemical equation which just represents that nitrogen is going to react with hydrogen to produce ammonia. But actually, does this chemical equation, is this balanced? Is it balanced, guys? Is that chemical equation balanced, guys?
Yes.
Is it balanced? We just here have 2, but here just 1 nitrogen. So how does
Mister,
it
there
balance?
is no picture. There's no picture.
What? You cannot see what I'm drawing?
I can see the introducing to skyometry.
Yeah, you can see what I'm just drawing here on the board.
Oh, no.
You can see it?
No, I can't.
Okay, just a minute. So here, guys, we say that, okay, so N2 plus H2, that produces NH3, okay? So here, as we can see, that's represent the idea, okay? That represent that. So what do you think this chemical equation, is it balanced?
Balanced.
Is it balanced?
No.
No. So here we have just 2, but here just we have 1, so it's not balanced. So we're supposed to add 2 here. So now we have 2 nitrogen, it's balanced, but 6 hydrogen, but here we have just 2, so we're gonna add 3 here. Like this, that is a balanced chemical equation. This balanced chemical equation, what could help us to predict the ratio? The ratio here in that reaction, that 1 mole, okay, of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. So that the ratio which we have. Okay, so like this in stoichiometry, the first thing that we should start with in any problem, that is a balanced chemical equation. Without a balanced chemical equation, we will not have the ratio or the quantitative ratio between the different compounds in the reaction. Is it clear, guys? Is that clear? So here, let's back to the point here, guys. We are gonna find, as you can see here, that we have 2 types of stoichiometry. So we have something we call composition stoichiometry and something we call the reaction stoichiometry. So what difference between the actually composition stoichiometry that which we studied in section 3, which represents, or chapter 3, that represent the amount or the relative masses between different elements in the same compound. That means we talk about one chemical substance. Like once we say H2O, it means it represents that 2 mole of hydrogens combined with 1 mole of oxygen, which means 2 grams of hydrogens, they are combined with 16 grams of oxygen to produce 1 water molecule. That is a composition stoichiometry as we studied in chapter 3. What we're going to study in that chapter actually is the reaction stoichiometry. And reaction stoichiometry, it represents the relative masses of different reactants and the products in a certain chemical reaction. And as we said, the first step in the stoichiometry problem is that we should have a balanced chemical equation. Okay, guys? Regarding this, we're going to have different types, okay, of problems regarding this stoichiometry or reaction stoichiometry. The first type or the first kind of the problems that could be here, that it could give you amount of, okay, substance in mole. This substance could be a reactant or a product, and ask you to find the amount of another substance, could be another reactant or a product also. So he given you, okay, the amount in mole and ask you to get the amount of the other substance also in mole, okay? And that's actually the simplest or the easiest part or easiest kind of this. So let's see here, guys, to understand. For example, we say that's here in that reaction. So Na, sorry guys, okay, Na reacts with chlorine. So it produces NaCl, okay? So regarding to this, we said that sodium reacts with chlorine to produce sodium chloride, NaCl. So I'm gonna just here. Okay, guys, here. So we said that Na, what the problem? So just tell me if that's a gap here on the screen. Do you see my drawing, guys? Can you see what I'm writing? Guys, can you see what I'm writing on the board? Guys, okay. Can you see what I'm writing now?
No, it was shown before.
It was shown before. So like this, can you see it? What I'm just writing right now.
الماوس اصلا يصير ما بيتحركش.
Okay, so just thanks. Okay, guys. Okay, guys. So here, just a minute. So, for example, we said that as we can see here, that kind, he said that once we say 1 mole of a substance and he required you to get another mole, like the equation which we said before, okay, that's N2 is gonna combine with H2, okay. I don't know what the problem, okay, that's produced an H3, okay. So here, as we said, the ratio, that's 1 mole of, I don't know what the problem in that. Okay, so guys, I think there is a problem in the board or something like that. So we're gonna continue this next time. We're gonna stop at this point, and next time, inshallah, we're gonna continue our session. Thank you and goodbye.